So today we'll be doing EMI AC. Actually, we should do optics in the 8th session. We're extending our sessions also. That should be fine, right? So today I will do EMI and AC. Okay. The inductance between A and D is 333. So how are they? Series or parallel? How are they, guys? Series or parallel? So they're in parallel. So inductors are like resistors. So in parallel, it's like 1 by 3 plus 1 by 3 plus 1 by 3. Invert that. Done. So we'll get how much? 1. Just joining the webinar. Right. So this is 1, guys. Oh, yeah. I hope this is clear. Why 1? All 3 are in parallel. So it is 1. Next. The power factor. The power factor of an AC circuit having resistance R, inductance L, connected in series and an angular velocity omega. So I'll give you a little idea. So what happens when you connect all these 3 in series? These AC circuits, EMI AC, they gave 1. So I'll make it small. So we have 3 things in series, no? So one is resistor, other is inductor, and the other one is capacitor. All 3 have connected to AC source, right? So this AC source, why am I not able to see the chat? Okay. So I'll be asking questions, try to send the answers. So current I flows. Same I flows in all 3 devices, right? This is resistance R, this is L, this is C. So you see the current I is the phasor, right? R will be this way. So current in the inductor, so lags the voltage VL this way and VC is this way. So because of that, the resultant Z will get this way, right? Resultant Z. And this is I. This angle is phi. So what we are asking is cos phi, power factor, right? The power factor is how much? Cos phi. Cos phi is how much? Base. So base will be resistance R, and this will be how much? Omega L. So cos phi is base is R by under root R square plus omega square L square. If there was capacitance there, if there was a capacitance, we would have written R square plus, instead of omega square L square, we have 1 by omega square C square. So generally, what is the formula of cos phi? R by root Z basically. Z is equal to how much? Root of R square plus XL minus XC whole square, or XC minus XL whole square. Anything is fine. XC minus XL or XL minus XC. So if XL is more, if XL is greater than XC, then inductance is leading, no. So I lags voltage by phi. If XC is greater than XL, if capacitive reactance is more than inductive reactance, then I leads V by phi. That is the only difference. Cos phi value, everything, the formula remains same, but so is it leads or lags depends on the which one is dominating there. Is it clear, guys? Hello? Yes. Okay. So this is plus. In a transformer, number of turns in primary is 140, and that in the secondary is 280. The current in primary is 4, then in the secondary coil. So secondary coil. So what is the formula for the transformer? So you know transformer, they are actually used only for AC circuits. Transformer for AC to AC. Rectifier, if you remember, it is AC to DC. Oscillator, DC to AC. Okay, these are the devices we got in our syllabus. DC to AC conversion, we have this. AC to DC. In semiconductor devices, we have this. And transformer. So what happens in transformer? This is the primary coil. This is the coil core. And this is the secondary coil. Primary, secondary, this is the core. The metal, whatever we use. So this is the input. and whatever you get, you can connect your load. This is load and this is your output. So I1 goes, I2 comes. This is E1, E2. Number of turns is N1, N2. So we know the relation N1 by N2 is E1 by E2, which is I2 by I1. Why I2 by I1? Using the power concept. So using the power concept, right? So in this, he said in the question, he was mentioning data. N1 is 140. Primary is how much? 140, and this is 280. 140, 280, right? And if current in primary, I1, this is N1, I1 is equal to 4 amperes. Now, is it easy for you how to calculate I2? So use this formula, these two relation. N1 is how much? 140. N2 is how much? 280. I2 we don't know. I1 is 4. 2s are. 2s are. I2 is how much? 2 amperes. Easy? So 2 amperes, right? Yeah, this is valid for ideal transformer. We have, right? So what if it is not an real transformer? I mean, the ideal one. So in that case, they'll give efficiency eta. That means P output is eta times eta by 100. If it is 90, 90 by 100 times P input. So in that case, P out is how much? I2 E2 is equal to eta by 100 into I1 E1. So now, if it is ideal, eta is 100. Am I right, Nishant? Right? So this is how you should do. If there is like, and there is a loss of energy. There is a, suppose eta is 90, there is 10% loss of energy. So this one is 2 amperes. Fourth one, a conducting sphere loop of side length L and resistance R moves in its plane with uniform velocity V perpendicular to one of its sides. So let this be question number 3, right? Yeah. A magnetic induction B, constant in time and space, pointing perpendicular into the plane. The loop exists everywhere within the half of the loop. Outside the field, I shown the figure. The induced EMF is fourth one. The induced EMF. Induced EMF. BIL. I is BVL is the voltage. Let us solve this. Right? BVL. But generally, I'll give an idea. It's easy question only. So how do we change the EMF? So basically, electric field and magnetic field are linked. When there is a changing magnetic field, we produce an electric field. When we change an electric field is there, it produces magnetic field. That is how a EM wave travels. EM wave, no, electric field, magnetic field, it travels. So this EMF chapter, we discuss only about, this EMF chapter discuss about changing magnetic field. So there is something called magnetic flux or phi B is equal to B dot A or BA cos theta. So B is the magnetic flux field at that point, A is the area, and this theta is the angle between area vector and B. When there's a changing flux, EMF is equal to minus d phi by dt. So now minus d by dt times BA cos theta. So there are 3 ways we can produce EMF: by changing B, or changing A, by changing theta. The different ways. So in this question, what we are doing, there is a magnetic field which is fixed, right? The rod is being pulled. So what is happening there? The whole loop. So there is magnetic field everywhere. The loop is being pulled out. Suppose if the question, magnetic field is everywhere. Now tell me the answer, guys. Magnetic field is everywhere. I am pulling the loop. The rod length is L, velocity is V, magnetic field is B. Now magnetic field is everywhere. Magnetic field is everywhere. What is the EMF produced? Others, any guesses? Nishant has answered, guess something, or he tried. Others? Right, 0. Why 0? If you see the area, let this be L and this is X. So what is the area? L into X. So flux initial is LXB, and afterwards also LXB, because a magnetic field is everywhere. Right, d by dt is 0. That flux is constant, phi is constant, so 0. What we are doing in this question, magnetic field is only there in the half region. So rest all is outside. So if you see, this region is decreasing. So I should only take this X, even though the length of the total one is L. What is the flux area? this L into this X only, not the complete length. So flux is equal to B into L into X. So EMF is equal to minus d phi by dt. So BL, differential of X is V, BLV. There is another option, BLV by R, that is a current flowing in the loop. If the resistance of the loop is R, current I is equal to BLV by R. Right? So what is the power dissipated? V into I, right? B square, L square, V square by R. This is the power dissipated. Right? If you are moving it with constant force, and if the velocity is V, because the force BIL is balanced by F. So force F is how much? BIL. Force F is how much? BIL. What is the power? F dot V. So whatever the power is given by the force, the same power is dissipated in the resistor. So net work done by that is lost in the power, heat energy using the resistor. Clear? I'm just trying to add as much knowledge, not just this question. So the coils, whatever we use, these coils in our home generators, North Pole, South Pole, we have a loop like this. So what we are doing here, B is constant, area is constant. When you're rotating it, the angle between B and area is changing. So B and this is theta. So angle between them is changing. Are you able to understand? So in this case, B into A into cos phi, phi is omega t. This is the flux. So EMF is equal to minus BA into differential of the sine omega t into omega, and minus into minus plus. So BA omega sine omega t. So this is why we are getting sine wave, right? So you can see that sine wave like this. Fine, guys. This is like EMI and how AC is produced. Not just this question, pura idea about that topic. Okay. So this is about the next question, fourth. Two coils are placed close to each other. The mutual inductance of pair of coils depends upon the rate at which currents are changing in the coil, relative position and orientation of the two coils, the material of the wires of the coils, the current in the two coils. You tell me, guys. So what is the main factor? So the rate at which current are changing, that changes the electric field. I mean that EMF, not the flux. He's asking inductance, the mutual inductance. Mutual inductance means basically it is like this way. You have your friend, right? How much you get influenced by his marks. Suppose he's in your class, you get influenced more. Suppose he is studying somewhere else, it might not influence you, right? So the rates at which it is not that, the relative position and orientation, right? Material of the coils, no. Due to material of the coils, R will change. If R will change, I will change, right? So mutual inductance, only relative position and orientation of the two coils. Option B, fifth one. Great, right, good. Sixth one, when the current changes from 2 to minus 2 in 0.05 seconds, in EMF 8 volts induced in a coil, the quotient of self-induction of the coil is. So EMF, what is the formula for EMF, man? This is how, which question? Sixth question, huh? Yeah. So EMF is equal to L di by dt, no? Or you can put minus sign also. So it is L di by dt. So EMF we gave 8 volts is equal to L, we don't know. Delta L by delta T. Delta I is how much? 2 minus or minus 4 by delta T, 0.05. Is that right, guys? So L is equal to 8 into 0.05 by 4, 2s are 0.1 Henry. L is equal to how much? Sorry, not 0.5, 0.1. Nah? Yeah, 0.1. Agreed? Any doubt in this? If they give you a function, if they say I is equal to 2t cube, then what is L value? Implies 8 is equal to L into 3 2s are 60 square. So L is equal to 8 by 60 square. So L is changing, it is not constant. I'm just giving an example. So it depends on how I is changing. Is that clear? Right. Next. Next question. Is he done? In an oscillating LC circuit, the maximum charge on the capacitor is Q. The charge on the capacitor and the energy is stored equally between the electric and magnetic field. Okay, let us see. Seventh question. Good question. So what exactly is LC circuit? No, there is an inductor. There is a capacitor. So what is happening? The maximum charge Q and minus Q when the current I is 0. What is the other extreme case? I is maximum. In that case, charge is 0. These are the extreme cases. So energy is E is here. In this case, E is here. He's asking the situation somewhere between when the charge is Q dash plus Q dash minus Q dash and current is I dash, but energy is E by 2, E by 2. That is what he's saying. This is the in-between case. So here, what is the energy E? E is equal to half CV square or half Q square by C. What is the energy here? Half L I square. If I is the I max, half L I square. In this case, half L I dash square or half Q dash square by C. So this he said is E by 2. So half Q dash square by C is equal to E by 2. E by 2 means half of half Q square by C. Half and C gets cancelled. Q dash is Q by 2 root 2. Q dash is how much? Q by root 2. How many of you understood this, guys? Q by root 2. You understood? Tell me. Ramnath understood. Karthik, Janakraman, Shiva, Lakshmi. 1 second. Ashini, Shivagomati, Lakshana. Okay. Rishwana, Jasmine, Isha. Once more. Yeah. Explain again, sir. Got it. So, what he said, I'll read the question again. In an oscillating LC circuit, the maximum charge on the capacitor is Q. Maximum charge means when I is 0, current is 0. The charge on the capacitor when the energy is stored equally between the electric and magnetic field. But it has to store equal. So what I took the case where energy in the capacitor is E. Energy in the capacitor is E. This is the maximum energy. What happens to this energy? It slowly leaks from this and this flows as a current like this and it comes to this. So in between stage where energies are equal. So E by 2, E by 2, no. Equal means half and half. So it is equal E by 2, I assume the charge is Q dash. So what is the first one? E is equal to half Q square by C. And the second one, E by 2 is equal to half Q dash square by C. So instead of E, I have substituted this. That's it. Done. Q dash is Q by 2, root 2. Is it clear, Rishwana and Ashik? Clear, guys? Shivagamati, done, sir. Now you too, Ashik and Rishwana. Are you guys there? Rishwana, right, you understood. And Ashik is not responding. Right, you also understood. Great. The core of any or transformer is laminated so as to reduce the energy loss due to eddy currents, make it lightweight, make it robust and strong, increase the secondary voltage. So we have these eddy currents, so losses. When the core is like solid, we have many arbitrary loops here and there. When you slice them, cut them. So imagine there is a road, okay? So if there is a 8-lane road, okay? So I'm just conceptually I'm explaining you why we do that. There is a highway. So now it is allowed for us to go on it like this. So what we'll do, one guy will go like this, one guy will go like this. You might be going like this, right? So the chances of accidents are more. So power loss is more. What is that energy loss? When current flows, electrons go hit it So right, that is why we have this loss. Same one, if I make lanes like this, what will happen? So this guy will go like this guy, and so there is no arbitrary, crossing the paths and all, so they won't cut. So these accidents got decreased. So when accidents get decreased, the loss of energy got decreased. You understood? So this core is like a chunk which you are cutting it into this and laminating. That means insulator. This is conceptual, but I'm trying to use the logic. Ninth one. In LCR series AC circuit, the voltage across each of the components LCR is 50. The voltage across LC combination will be 0. Am I right? Why? So ninth question, there is a LCR. And in this is VL. So this is VR. This is current I. This is VL and VC. So this he gave 50, this also 50, this also 50. It's like two vectors, they cancel each other. No. So we only have VR. So basically it happens when this is VR, VL, VC. VL is equal to VC when XC is equal to XL, same current flows. That means resonance. 1 by omega C is omega L, or L is equal to 1 by root. Sorry, omega is 1 by root LC. So when only at resonance this happens, and resonance only the resistance. Current is in phase with the resistor. Voltage with of resistor. Ninth one. When do you have 50 root 2? When the voltage about L and R, C combinedly is 50, then we have 50 root 2. They're just like vectors, guys, nothing more. Tenth one, batao. So DC, how does DC work? DC device measures your average value. AC device is called hardware instruments. It is based on the heat dissipated. So here average value of AC is how much? Average of AC is equal to 0. Symmetric AC. So average value, say AC cannot pass through DC. It is not like that. AC changes direction. That is right. It's not because of that. So average value जो है वो 0 हो जा रहा है, इसीलिए we are getting it as 0. So done decently. Can take this as homework. Let us do 24. In AC circuit, the voltage applied is E naught sin omega t. The resonating current in the circuit, resulting current is omega t minus 5. The power consumption in the circuit. So what is the power factor is 5 by 2, no, or minus 5 by 2. If you see current leads voltage, it is 5 by 2. Cos phi is 0. So 24th, what is the answer? 0. What can you tell from this value? Is it inductive circuit or capacitive circuit or resistive circuit? What is the resistance value in the circuit? What is the R in the circuit? So power factor cos phi is R by Z. So cos pi by 2 is 0. That means R is 0. Are you able to understand? R is 0. Current is lagging voltage. That means it is inductive circuit. If I have plus here, it is capacitive circuit. Are you able to understand? So this 10th one, which question is it? 24. So phi. Basically what I do, V is equal to V naught sine omega t, I is equal to I naught sine omega t plus phi. Right? If phi is positive, what is the meaning? Current is leading voltage. That means XC greater than XL. If phi is negative, that means current is lagging voltage. XL greater than XC. Phi is 0. That means XL is equal to XC. Agreed? If phi, so the one of the cases, phi is equal to pi by 2. Phi is equal to plus pi by 2. That means current is leading, right? That means XC is dominating. XC is dominating basically, and R is 0 again. So in this case, XC is greater than XL and R is 0. Are you able to understand? Similarly here, phi is equal to minus pi by 2. XC less than XL, still R is 0. So when I say phi is pi by 2, the first thing we can say is R is 0. Plus ante, it is not purely capacitive. That doesn't mean it is pure capacitive. Capacitance is more than inductor. There can be inductor, but also it can be zero. Capacitance is for sure. Inductor you cannot tell for sure. I hope I'm making sense, guys. Twenty-sixth. What is a mutual inductance? So mutual induct, we have self-inductance, which is mu naught n square into area into L. So self-inductance L, which is mu naught n square into area into L. Mutual inductance is mu naught into N1, N2. I just remember this. Instead of n square, N1, N2. This area of intersection into L. L is the length. This area is the area of the loop. If this area of the loop is A, this is A. But this area, these are different areas. So one loop is bigger, A1. The other loop is smaller, A2. So which area should I take, A1 or A2? Which area should I take, guys, A1 or A2? Smaller one, A2. Agreed. So this should be A2, smaller area. That is the resultant area. I should say resultant, a projected area kind of thing. So in this question, he was saying, I hope mutual inductance ka formula revise ho gaya, and we are also discussing self-inductance and which area we have to consider. This is where people do mistake. So area is 10 centimeters square, length is 20. So see the units. So A1, he gave 10 into 10 power minus 4. Length is equal to 20. Yeah? 20 into 10 power minus 2 meters, meter square area. Then N1, if one of the solenoids, N1 is equal to 300, N2 is equal to 400. But this N1 and N2 are capital N1s, capital N2s. It is not per unit length. That is capital N1 and capital N2. So what I should do, M is mu naught into small N1 is capital N1 by L into capital N2 by L into area, resultant area into length L. One L gets cancelled. Don't get confused. Small N1 is in the formula. In the question they gave capital N1. If you don't do that, you'll get the wrong answer. So mu naught, we have 4 pi into 10 power minus 7. N1 is 300, N2 is 400. Area is 10 into 10 power minus 3. Or 10 into 10 power minus 4. I can write it as 10 power minus 3. Am I right? By length L, 20 into 10 power minus 2. So this is 1 minus 1 will be there. So 20. 20s are. So 3 2s are 6, 6 4s are 24 pi into 10 power minus 7 minus 1 minus 8. And we have 3. So 10 power minus 5. Right? This is 2.4 pi into 10 power minus 4 Henry. So pi you can leave, the option is there in terms of pi. If it is not in that, multiply with 3.14, 3 2s are 6 point something will get. So answer is in 2.4 pi into 10 power minus 4. Another one is there, 10 power minus 5. That is 24 hoga to 10 power minus 5. But we have to use 2.4. Clear, bacho? Guys? 25th. An ideal coil of 10 Henry is connected in series with a resistance of 5 and a battery of 5 volts. 2 seconds after the connection is made, the current flowing in the ampere. Okay, good question. There is an inductor, question number 25. Inductor coil, 10 Henry. There is a resistance, 5 ohms. There is a voltage, so battery, positive, just DC battery, 5 volts. It is growth circuit, decay circuit, if you remember. So current I will start with 0 because inductor is the one which is stopping it. No. So how do we remember this? I is equal to I naught into 1 minus e power minus t by tau. This is the formula, right? Now, what is the I naught value? That is the maximum current. What is the maximum current? When when t is infinity, I max is equal to V naught by R. So V naught is how much? 5. R is 5 to 1 minus e power minus t by tau. Tau is the time constant. How much is it? Time constant. L by R. Am I right? L by R. Time constant is L by R. So this is one. So how to remember this formula? Either it is this is growth circuit 1 minus e power minus t by tau. Decay circuit I naught e power minus t by tau. That is the difference. So it is 1 into that is 1 minus e power. What is the tau here? T is equal to 2 seconds. T is equal to 2 into R goes to the numerator 5. Inductor is 10. So 1. So 1 minus e power minus 1. 1 minus e power minus 1. Okay. 25. Clear? Nice man, Ramanathan. You try to still answer it. Nice. Akshini, right. Good that you people are able to understand, man. I'm so happy. There are decent questions now in this one. If you want, take screenshots, guys. Shall I move it like this? No, this way only. So take screenshots. This one. So we are done around 3 in this. Flux 5, the induced EMF at 3. So again, I'm not able to see myself. So 20-second flux is equal to EMF is equal to minus d5 by dt. So it is minus of 10 into t square 20t minus 50, right? When t is equal to 3 seconds, substitute minus of 20 into 3 minus 50. How much is it? 60 minus 50, 10. So 20-second, how much is it? Minus 10, minus 10 volts. He also gave 10 volts. If both options are there, I will go for minus 10. If one option is there, only 10, I'll go for 10. Okay. Take screenshot of this page. I don't think we did anything in this. Only one question we did. Again, we have AC circuits and all. You can do it. So take screenshot and start working in this. Is it done, guys? See, a circuit has 12 ohms resistance and a 15 ohm impedance. That is, R is this, Z is 15. So power factor cos phi is R by Z, 12 by 15, easy. 4 by 5, right? 37 degrees. Cos means 4 by 5, 0.8. 19. The phase difference between I'm just trying to give how fast we should see. Phase difference between alternating current and EMF is pi by 2. Which of the following cannot be the constituent of the circuit? So one is R, right? R is for sure. Cannot be the constituent of the circuit. R and L. If R is there, it cannot be pi by 2 in any case. So R and L. In a series resonant RLC, the voltage across R is 100 volts. R is 1 kilo ohm, C is 2. Resonance frequency is 200. Resonance, the voltage across L is. So how do you get it? Voltage across L. So what is the total voltage he gave? Omega he gave. So voltage of the source is equal to voltage of the resistor. Agreed? So what is the current? So current is, are you able at resonance? 20th question, at resonance. VL is equal to VC. VR is equal to VS. S means source. He said this is 100 volts. So which is voltage of source. Current is V by R. VS by R. Current I. So VS is 100 by what is the resistance value? 1 kilo ohm. 1000. So 0.1 ampere. That is the I value. Now what about XL is omega L. Omega is how much? He gave omega is 200. And L is how much he gave? Oh, he didn't give L. So you have to find out. So L, which is equal to XC, right? Which is 1 by omega C. So 1 by 200 into C. C is how much he gave? C is 2 microfarad. So I don't think He's asking the voltage. Huh? Okay. So you can also find out the voltage about capacitor. So here these two are there. So no need to find out L and all. See the VC, voltage about C is I into XC. I is how much? 0.1. XC is 1 by omega C. Omega is 200. And C value is 2 microfarad. 2 into 10 power minus 6. This 10 power minus 4 numerator plus 4. So plus 4 means 0.1, 1000 by 4, 250. Am I right? Am I right, guys? So we in the exam we can solve things quickly actually. Okay. So 21, the maximum voltage. How much? We already did. A into B into A will be there, B will be there. Omega will come out of the different because of the differentiation. If number of turns is N A B the omega. That is the voltage maximum. Fourteenth one, a metal conductor of length L, 1 meter, rotates vertically about one of its ends, angular omega velocity 5 radian per second. Then the horizontal magnetic field 0.2 into 10 power minus 4 EMF. So 14th question, I'm explaining you. Question is, there is a rod. Length of the rod is L. You're rotating about this point A. Angular velocity is omega. So I'll tell you in short, EMF is equal to normally BVL, no? So what we will do, B into L into V average of the ends. So B into L. What is the average velocity, guys? One is velocity of this end is omega L. Velocity of this end is 0. What is the average? Omega L by 2. So B omega L square by 2. Are you able to understand the EMF produced between A and B is B omega L square by 2? Clear? So why this is happening? Imagine you are the electron. When you're rotating it, electron will try to move out. No, it is like free electron, it is trying to move out. So few electrons will come here, few electrons will form a group here. So negative charge. As they move, it will get positive charge. The plus and minus, it's not exactly the end, they will also be there on the way. So due to this plus and minus, there is an electric field E. This is the induced electric field, due to which we have an EMF. That EMF is this. So when you integrate E dot dl from here to here, so if they say, if I connect a resistor R, if they ask you from where to where the current will flow, electrons will flow. Electrons will flow from B to A. Current will flow from A to B. Right? These are the logics why this is happening. If you can get it, that's going to be wonderful. Right? You have taken screenshot. First page we have done. Right? Easy only. Second, we have done few. So in this question, put omega is 5, B is this, L is equal to 1. Done. So it is actually a combination of EMF and AC. We have ray optics and then we have wave optics. Then EM waves. EM waves should have been done. So this is next. We have 2 more sessions. No? What are those 2 more sessions? One is atomic and nuclear physics. The other one is semiconductor devices and communication systems. So at that time, we'll discuss electromagnetic waves. Okay. We'll take another class if needed. So no worries, guys. I'm here for you. So, bachcho. Right. Question number 1. Give a try. I'm giving you time. If 2 minutes are kept at 60 degrees to each other, then the number of images found by them is 360 by theta is even you have to subtract 1, no? So how much is it? Integer basically. Then you have to subtract 1. 5. So first one. So I generally forget this formula. So what I'll do, this question number 1, ray optics. There is one mirror. Object here, image 1. So 360 by 180 is how much? 2. But I know one image, so minus 1. This is the formula. Even if you forget in exam, 360 by theta minus 1. Integral part of it. Right? Suppose fraction is there. Sometimes we might get more also. Like theta is like 179. We get 2 images. So we get around 1.001, but we get kind of higher integer. So if theta is this, theta is 179 degrees, not 180. How many images will get? One here, 2 images. So 360 by 179 is little more than 1, no? That means I should write 2 is the answer. Are you able to understand? I mean, it is more than 2, little more than 2. So little more than 2. Still we have, in that case, we are not subtracting 1. Yeah, so we are getting 2. So no need to subtract 1. Are you able to understand this? This one integer is आ रहा है, तो एक चले जा रहा है उसमें. So one image is like overlapping. Similar case scenario works when theta is 90 degrees. When theta is 90, is the object I1, and in this I2 behaves like an object for this, I1 as an object for this. This is the I3. We have 3. This is 90 degrees. Through 360 by 90, which is 4, but we have 4 minus 1 is the number of images. Am I right? So this I3, I4 are overlapping and becoming I3. If I say it is 89 degrees, we'll get 4 point something. We'll get I3, I4, 2 different symbols. So just 89, like little tilted. In that case, we have I1, I2, I3, I4. We have 4 images. When theta is 89 degrees. Are you able to understand this? I'm just giving, see, a 90 everyone will do. In mains, they will ask you 89 degrees or 91 degrees. That is where thoda dimag use karna. Suppose he says 59 degrees. Now I cannot solve. So why I'm telling you 90 degrees? 59 means I cannot draw, 2 mirrors and draw all the images. So I'll do for 90 to 89. If they say 59, I'll do 90, 89. If they say 61, I'll do 90, 91. So if the angle is 90, how many images? 91 means how many will come? Are you able to understand? Even if it is 91, we are getting 4 images again. So go with the logic, guys. So in this case, 60, so 5, easy. Second question. So resolving power is inversely proportional to lambda. Some 1.22 something f by some lambda will be there. If you remember, that is actually wave optics. I don't know why he gave it here. It is inversely proportional to lambda, resolving power. So what exactly is resolving power? This is question number 2. There are 2 small bulbs, B1, B2. When you are nearby these bulbs, what happens nearby these bulbs? They are like B1, B2, 2 different bulbs. Like there is a bus coming from very far. When it is very far, it seems like a bike is coming. You cannot see 2 bulbs, right? You only see single bulb. But when the bus comes near to you, now you can identify 2 different bulbs. Am I right or not? So that is what meant by resolving. So 2 dots are there. You have to identify them as 2 dots. Suppose I keep these 2 B and B1, B2, and your friend is able to see them clearly as 2 different dots. And you are only able to see it as 1 dot. That means your resolving power is less. Your eye's resolving power is lesser than your friend's eye's resolving power. And that depends on the wavelength of the light. So there are 2 buses. One bus is coming with red light, another is coming with violet light. So 1 by lambda, violet light ka resolving power is more. So when the 2 buses are at the same distance, the violet one you can see them as 2 different bulbs than this one. So resolving power is more. Are you able to understand? This is very logical, guys. I'm just giving you the real-time application of what you are trying to do. Right? Nice. Good to hear that. So lambda P1 by P, resolving power R1 by R2, or power whatever thing you want to call. So lambda 2 by lambda 1, 5:4. And one more thing, in final mains exam, you have to use the elimination method. And also, you have to be cautious about the options. The options will be such that they will tempt you to commit mistakes. This is one thing what they will do. Yesterday, I was talking to one guy, he's a student. He got into IIT, his kid, I mean. But still, he did few mistakes. So, one mistake, what he said, just example I'm giving. So, if the answer was suppose 24 by 160 or something, he got it. The option one was 25 by 160. Right? Option last one is 3 by 20. 8 threes are 8 threes are no. So what this guy did, 24 by 160, he thought I might have done mistakes. So the nearest option is this, so he marked this. The actual answer is option D. You understood how you got tempted. Though you solved, you did invested, you did. Your friend might have left this question. He's safe. You have invested time, you solved it, you got negative marks. So you lost time and you got negative marks. So you understood what I am trying to say. If you are investing, you should do it right, or else better leave the question. If you're investing on a question, make sure you get the right answer. That doesn't mean you should invest 10 minutes on it. No, that is not what I'm trying to say. What I'm trying to tell you is you should do it accurately. Don't do any mistakes. Give your best till the end. So check all four options. Sometimes dimensionally they might wrong, or you might see odd one out. There are many things. Generally, odd one out, it might not be the answer. If there are four options, one might be like length is asking, one is in in terms of some other units, degree centigrade. So no need to do it right. So please be cautious about the units. Which of the following using optical fibers? Total internal reflection. These days, in many things, you are using it. Right? Easy one. An astronomical telescope has a large aperture to reduce spherical aberration, high resolution, increase span of observation, have low dispersion. What is the answer, guys? So resolution formula mein we write that diameter d of the this one. No, it's not spherical aberration, guys. For spherical aberration, we paint the external, so for aberration, fourth one, no, we have a lens, so we paint it, the outer, nearly outer, we paint it to decrease spherical aberration. It is not what is happening there. Larger the area, larger light goes in, more collection of intensity, and we have the diameter d or a we call in the formula, right? So for resolution, guys, like when we have stars which are very far, you see with your naked eyes. For you, it seems to be a single star from here, just like the bus I told. No, when they are very far, it looks like a single star. But when you use this, right, we can see that. That is why you use telescope, no, to see that they are two. Simple. Have high resolution. The image found by an object of a compound microscope is virtual and enlarged, no? Or real and enlarged. Fifth one, microscope. Right? The first one, due to objective, will be real and enlarged. The second one will be virtual and enlarged. The first one will be real and enlarged. Like objective, real and enlarged. Eyepiece. If you ask eyepiece, what about eyepiece? Eyepiece, virtual and enlarged. Are you able to understand? Virtual and enlarged, the fifth one. Real and enlarged, no? So we have this. See, again, if it is microscope, छोटा इधर ऑब्जेक्टिव एंड आईपीस ऐसा रहेगा. इफ इट इज माइक्रो, इफ इट इज टेली, ज्यादा लाइट चाहिए, बड़ा होगा, छोटा आंख है, तो दिस इज आईपीस, दिस इज ऑब्जेक्ट. रिवर्स होता हियर माइक्रोस्कोप में वी पुट लाइट बट यू हैव टू कंट्रोल, सो इट इज डिफरेंट. To get three images of a single object, one should have two plane mirrors at an angle. You already solved 6-1. 90 degrees. Three images. 360 by theta minus 1. 90, no? Ninth question seems to be interesting. Let us see. A light rays incident, seventh one, perpendicular to one of the face of at 90 degrees prism and is total internal reflected. If the angle of reflection is 45, we conclude that the refractive index n is. So eta. So what? See, TR is happening for 45 degrees. TIR is happening for 95 degrees, 45 degrees. So we have the seventh one. What is the formula for critical angle, guys? Right? Mu is greater than 1 by sine theta c. Theta c is critical angle. Agreed or not? So mu is greater than. So in this question, what is mu value, guys? That is what we have to find, no? Did he give this? Yeah. So if this is mu, refractive index of this. So I, the angle of incident, 45 degrees is greater than critical angle or not? 45 degrees is greater than critical angle. Sine 45 greater than sine IC. Right? I'm sorry, someone is doing this noise. So 1 by root 2 is greater than sine IC, right? So what is the relation we are getting? N. One by sine IC. So if I reverse it, it is greater than root 2. It is greater than root 2. From that I can say, so mu is greater than 1 by sine IC or theta c, critical angle, which is greater than root 2. So mu is greater than root 2. Are you able to understand? We know this condition. For 45 is greater than critical angle, then only we are having this TIR. Just applied sign. Right. Easy only. Just try to give the explanation of it. So n greater than root 2. A plano-convex lens of refractive index 1.5 and radius of curvature 30 is silvered at the curved surface. Now this lens has been used to form the image of an object. Now this lens has been used to form the image of an object. So what distance from this lens an object is placed in order to have a real image of the size of the object? Sorry, someone is. So plano-convex lens, right? And he has silvered at the curved surface. Okay. So whatever ray goes, so this behaves like a concave mirror, no? This behaves like a concave mirror. It goes, then gets reflected because of this, right? It is like a concave mirror. Agreed? Surface is silvered. So what is the power? So what is the F of a concave mirror now? He gave focal length is how much? R is 30 degrees, 30 centimeters. Mu is equal to 1.5. Oh, he's saying it should be same as the mm, so like object and image should be of same size. That means equivalent. So I have to replace this with the equivalent concave mirror. So what is the focal length of this equivalent concave mirror? So it is plain here, no? So what is the power of this basically? What is the focal length of this? 1 by f is mu2 1 minus 1 into 1 by r1 minus 1 by r2. So 1 is infinity, 1 is r, right? So 0.5 by r. Our focal length is 2r. This is the focal length of single lens. Now, ray has to go and come back. No, it is like reflection is happening. So 2 times refraction will happen. So focal length of this f dash will be half of this. 2 times. Now power becomes double. So focal length becomes f by 2. So 2r by 2, which is equivalent 1. Is again we are getting r. Huh? Is it 2r we are getting? Convex lens, concave. Am I right, guys? What is that equivalent focal length of the first one? Mu2 by mu1, which is 1.5 by 1 minus 1 into 1 by r2 minus 1 by r1. 1 is infinity. R is how much? 30, or I'm just putting it as r. So 0.5 by r. So f is equal to r by 0.5. But it is converging, no? Am I doing mistake somewhere? (1.5 minus 1 only, no? Any suggestion there? In that case, I'll be getting 60, but 20. Is the answer 60 or option? I'm getting 69. Is it coming 60? But single, it is a convex lens, no? He said convex lens. For a convex lens of r is equal to 30 centimeters, mu is equal to 1.5. What is the focal length, guys? So I'm getting 60 centimeters. Am I right in this section? Yeah, R1 is 30, R2 is infinity. So we are getting our focal length is 60, no? Right? So I guess focal length f of the lens is equal to 60 centimeters. Then focal length of the mirror will 2 times. Basically, 1 by f equivalent is 1 by 2 times 2 by f of the lens plus 1 by f of mirror. Okay, powers get added. Agreed? So I guess we are getting 60. So this will be 30 centimeters. But he said 2f, no. So because object distance u and v should be same, equal in value. That means that u is equal to 2f dash. I'm getting 60 centimeters. How much you are getting? Are you able to understand this? See, there is, I'll explain again. There is a plano convex lens, guys. The radius of this is 30 centimeters. Radius of this is infinity. Mu is equal to 1.5. What is the focal length of this lens? Tell me the focal length of this lens. Focal length of this lens, guys. 1 by f, lens maker's formula. Mu2 by mu1 minus 1 into 1 by r1 minus 1 by r2. Am I right? So mu2 1, how much is it? 1.5 by 1 minus 1, 1 by 30 minus 1 by infinity. So what is the f value? 1.5 minus 1.5 by 30. 1 by f is 0.5 by 30, or f is 60 centimeters. Plus, why plus? This is convex lens. Any doubts in this? F is equal to plus 60 centimeters. Right? So what I'm doing now, I am covering this part. So the ray goes inside, it gets reflected, it converges. Agreed? So again, after reflection, again there will be refraction here. No. So 2 times the ray is going through the lens and 1 time reflection. Agreed? Yeah. So it is like a curved mirror. So okay, I have missed one. So that is not just this. We should also add the mirror because lens is converging, mirror is also converging. Lens is converging, mirror is also converging. So 1 by F equivalent is, we have to use this formula. So 1 by F equivalent is 2 times the, see basically it is equivalent power. P equivalent is 2 times power of lens plus power of mirror, right? So 1 by F equivalent is 2 times. What is the power of lens? 1 by 60, right? Plus power of mirror. What is the power of mirror? Mirror radius is 30. So what is the focal length of the mirror? 15. What is the focal length of mirror, guys? So radius of the mirror is 30. So focal length is 15. Are you able to understand so far? 2 times refraction due to the mirror, due to the lens, it is 60. Due to the mirror, it is 15. Right? Both the powers adding. Why am I adding both the powers? Why not subtracting? The lens is also converging. Agreed or not? The lens is also converging. Also the mirror is converging. So what it should have been? So 1 by 30. I'll tell you the twist at the end. Okay. So how much is 1 by 30 plus 1 by 15? How much is it, guys? 3 by 30. So F equivalent is how much? 10. Agreed? F equivalent is 10. So how much is that we are getting? So U is equal to V is equal to R, which is 2F, no? So 20 centimeters. Is that clear? So this is wrong. Because why is it wrong? I missed this part of mirror. Why I missed? I'll tell you. Instead of painting this way, same question, I paint the mirror part. This one, flat part. This is different question, this is different question. In this case, P equivalent is 2 times power of lens plus power of mirror. Power of mirror is 0 because it is a flat mirror. In this case, only lens will come what I did was right, 60 centimeters. Agreed? Any doubts with anyone? Right? So we have done ray optics questions, guys. So answer we are getting 20 centimeters. In order to have a real image of the size, in order to, that means size of the image and object are same. At what distance from this lens, an object be placed? That means object distance is asking. So that the size of the image and object are same. He's not asking the size of the object because he haven't given the size of the image. So you cannot find it. Clear, bachon? Right? Is it done? Can you take screenshot, guys? I'll also show the key, right? Take the screenshot quickly. So recap the formulas, whatever we have, and try to solve the questions. They are easy. So for little practice, I'm giving you this. Once it's done, you have this collection of 42 years and all. Please do that. Right? Take this also if you need it. Okay. So next session, we'll have wave optics and that's atomic and nuclear electrons and protons, and we have atoms, molecules, and this one. Okay, nuclei. If something is pending, we can add that with this. I don't think they have given this separately. Communications and this they have added. So we can do it together. Clear, guys? So we have got little extended the session. Sorry for that. Any doubts for anyone? Is it fine? So how is the preparation going? Have you guys got that sheets and all with you? 45 years and 42 years and all?